at this point we could go and create the word cloud from this data that contains the top word. But by looking at this top word, you can clearly see we have just a little meaning to this top word. You can see these words like have. Here we have this, that is cause. You can see some of the stop words here. So before creating the word cloud, I want to remove these stop words. So let us do that now, and we will be creating word cloud. So what I'm going to do is I'm going to just import a counter that will count the word for me, and I will create the word list, and for comedian in data dot columns. So what is this data? This data is the same data that we have been working, that was right here, this data, which is our transpose of document DOM matrix. So we loop around and we got each of the comedian name. Now I want to extract the word for each of the word and count in our dictionary, and we have already created this all the dictionary. Now I got the top word, all the top word in fact, and for top in top I want to append it in the words, and the word that I want to append is T. So I'm going to loop around all the words in this top, and I'm going to append it into the words list. Now if I append it right here, see here, what we will get is these words, all the words, all the top words in fact. So previously we distinguish between these comedians. Now we have the centralized list where we have all the words, the top words that has been spoken by our comedians into the single list. Now after getting the top words into the central words list, see here, all the words, we are not differentiating now among the that is comedians, rather we have the combined list of all the top words that has been spoken by all of the comedians into the single list. Now I can call this counter, that is the module that we have imported. See here at the top, here we have imported the counter. So I can use this counter and call, that is words with it, that we have just created the words, and I will pass here the most common word, and this is the function that is defined inside the counter. So you can see within this top spoken word we have the word like, that is spoken 12 times, no, that has been spoken 12 times, and so on. This is the counter basically. So counter will count the word, its frequency, basically the frequency will be generated and it will be displayed right here. Now next thing is, let's say I want to just go down, and right here what I can do is I want to create something called as add stop words, and here what I'm going to do is I'm going to loop around each of these words, word and counts, in this counter that we have just created. See here, this most common counter, I can copy it and I will paste it right here by looping around it. So what I have done here is, so I have extracted the word and its count one by one for each of these words. So that is all I have done right here, and I'm checking if the count of it is greater than 6. So basically I'm going to extract more frequent word that has a count greater than 6. So I'm going to remove this type of word, like that has these words that has the lower frequency. I'm going to remove it. So if I run this, we got invalid syntax because we need to add a word here. I have to give the expression also. So there's a word there is the loop, and there is the condition. So it should be not id, it should be if. So this is the list comprehension if you don't know about it. So the first thing here will be expression, the second thing is the loop. So in our case this is a whole for loop, and then we have these conditions. Now if I run it, then you will see again the error because the name count was not defined, it was counts here, so it should be count. So now if I run it again, now stop words has been created. I can print all of these stop words. Let's go here and I'll print these stop words, because in any sentence the word that mostly likely occur are the stop words. See here, so these likes, like, no, these things, I think they are the stop word because they don't have a significance meaning. Do you think this word have a significance meaning? Not. But word like this, murder, course, wife, cow, maybe some of the topics of world, so these have some meaning. So we are going to use those words and basically remove these words because they are the stop words and they don't likely give some meaning to our, that is, visualization or to our analysis. So that is the reason we have extracted add stop word. We found what are the stop word that our comedian are likely using. Now let us update our document term matrix using this new list of stop word. So for that I am going to use the scikit-learn feature extraction, and I am going to import text. I'll show you in a minute what I am going to do with this module, but for now let us just import it. And next is feature extraction dot text. I want to import count vectorizer. If you remember, we have already used this module in order to create a document term matrix. I'll run it. Let us go down, and I'm going to basically create a stop words, the new stop words that I have created. Stop words text dot English stop words. So now from this text I have imported the English stop word. If I just print this line for you, then you can see these are the predefined stop words. These are the predefined stop words. And now what I want is, along with these predefined stop words that I have imported, so this is defined for us to use, I want to add our own stop words that we have created. See here, this is our own list of the stop words. So I'm going to combine it with that. So I will just call union function to concatenate to the stop words, and I will add our own stop words. This thing that we have just created here will be added to the predefined stop words. Now I can just run this code, and now we have a list of stop words that needs to be removed. And after removing those stop words from our word that has been spoken by the comedian, we can render our word cloud. Now here I can recreate a term document matrix again. So for that I'll create a CV. This is the object of count vectorizer. It is the same process that we have done before. We can also copy it from the opcode, but here I'll just pass stop words is equal to our stop words. So this is stop word. So let us pass it right here. So this is an argument that expects the stop words. Now I can create a data CV where I can fit transform our stop words. Basically it will remove. So from the data clean I can just have the transcript that will convert it. So if you remember this data clean, it was way up where we have this firstly created data clean. So this object. So data clean, in this data clean we have the transcript, and in this transcript I want to remove the stop words. All the stop words has been removed now. Next thing, after we remove all the stop words, I'm going to create data stop, and this data stop will be our pandas data frame. Here I will just say data.cb to array. We have already done this. I'm just repeating the stop after we remove the stop word. So stop word has been removed. Now let us get features name. So get feature names is basically our column. So now I can just take this data stop and put the index to it. And what is the index? Index is a comedian name. So from the data clean, I want the index. So this is for our comedian names. Now you can also run this code, and here we got an error. Get features name is not defined. Get features, it is not just a feature, not features. So let us run it. So has no attribute. Get feature names. It should be names, not name. Get feature names. So let us run it. Now everything looks fine. Let us go down and let us print our newly created DOM document matrix after removing the stop word. Let us run it. See here. Now most of the word has removed, that is stop word. See here we have a meaningful word only now. Now let us use this meaningful word to create a word cloud. Now if you do not know about the word cloud are something like this. See here we have this word cloud where each of these words are displayed, and those words which has the highest frequency, which occurs mostly, has the bigger size. See here in this, that is word cloud, we can see the word like wars, star, film, series. They are in the bigger and wider. They are bigger basically in this word cloud, because in this word cloud maybe these words came mostly, or basically the frequency of these words in this word clouds is the highest. The word like, if you just open it, maybe I can just open my word cloud, then you can see in here we have some word like dark, and we can also go to this small word right here. You can see here it is the word journal. So the word journal has really less or really small, it is really small, because the frequency of this word journal is small. So that is the reason. So bigger word will have bigger frequency, small word will have small frequency. Now in our case we want to check which word has the higher frequency and which does not. So for that I'm going to import word cloud. From word cloud I will import word cloud. So in order to use this you need to install the word cloud. So open your terminal and type this conda install -c conda first word cloud. So this is the command. So let me copy it, go to the search and search for you need to search for conda command, or you can search anaconda prompt. Anaconda prompt, just open this app anaconda prompt. You can search it going to the search bar, and here in the anaconda prompt paste the command which will install the word cloud. Conda install -c conda force word cloud. If I hit enter, then in my case word cloud has already been installed, so I'll get command probably of saying anaconda has already word cloud installed to it. if it is not installed at your case, then you need to install in order to use this word cloud. Now after you have imported the word cloud, next thing I will create a word cloud object, and I'll say word cloud, the instantiate this word cloud, and pass here stop words as the stop words. I'll just render the word cloud for the stop words for now, and I'll just give the background color, let's say it is white, and color map is basically the color that you want to give for your text, and you can give the maximum font size also. So these are all the optional argument that you can have. I want 150 units as a maximum font size, and to have the reproducibility of the figure, I will give the random state 42, so that your figure and my figure will match. So for that you can also have the same random state. If you change the random state to something else, you might have a little bit different figure. So if I run it, then now word cloud has been basically created with the object word cloud. You can also do something like, let us remove this object and let us run it. Then you can see it is just an object, so I want to store it somewhere. Now let us render this word cloud now. So let us go down. I need to render or display this word cloud. So for displaying, I'm going to import matplotlib dot pyplot as plt, and I'm going to reset the output dimension first with this rc params. Basically I want to give the figure size. It is optional if you want to do it. If you do it, you will have a better figure. So I will have the different figure size for them, and my dimension of the figure size I want is 16 by 6. And next, after resetting the dimension, maybe I want to give the name for each of these comedians, but for now let us create subplots for each of these comedians. So I'm going to go index and comedian in enumerate, and I'm going inside these columns of the data, and using this word cloud, the object that I have just created, I can call this generate function for each of these, and I will pass the thing that I need to use, that is data clean dot transcript. If you remember, the word are inside the transcript column, and I need to pass the name of a comedian. So this will generate the word cloud for us. Now plot the subplot using the matplotlib, give the dimension index +1. So basically this will be the plot for each comedian. We will have a separate plot, and now I can show the plot, and what I need to show is a word cloud. I can have the interpolation, that is bilinear. Let us run at this moment and let us see that we got this thing, but it has no argument interpolation. Is bilinear. So it should be not only so, because this is an image show. I'll just I am so. Let's make it I am so. Let us run it. So see here, we got the word cloud, and we got word cloud for 12 comedians. So first, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12. And we have some of the words like see here, yes, t, and these are all we got from the stop words. What we can do is we can make something like we can have the names for each of these graphs. Like we don't know which graph is representing the comedian, which comedian represents which graph. So for that I can just create a name, and the first plot was for Ali, the second plot was for Anthony. So how did I got this is, if you go to the data.columns, you will find their values. So where is the data? So data should be somewhere here at the top. So this is data underscore DTM. So this is the data clean. You can see the first Ali, Anthony, Bill, Bo, and so on. So I will write their name one by one right here. So after Anthony it is Bill, and then we have Bo Berman, and then Dave, all the 12 names, and Hassan. The next comedian is Jim. The next one is Joe, then John, then we have Louis, then Mike, and finally we have Ricky. Now I have created a list of names of each of these 12 comedians. Now in this plot I want to give the title for them. So plt dot title, and I'll just say names, and I'll pass the index to it. So names is this same names list, and pass the index from this each of these values. So if I run it, then names is not defined, it is names. Okay, so now everything looks fine. Let us give some time. It will plot the word cloud for each of the comedians. So we can see the name has been also printed, but along with it you can see the word and the basically these values has been printed. So what I can do is I can just give maybe new line before rendering the title. Let us do it one more time and let us check how it works. So here the plot has been just generated, but see here, rather than generating the words, so what I got was the slash n basically. So I need to remove it, it didn't work. What I'll do is I'll just have the axis off. So this axis off will just remove these axis, the values, like you can see 100, 200, and this y axis 100, 150, 0. So we can remove it by just making this axis off. And after the loop is finished, I can also call the show method, and if I run it now, then it should work. Let us give some time to render it. So this is our final word cloud for each of the comedians. So you can see the Ali basically says yes word a lot, and there is Ricky Gervais who is also basically saying the F word, and John basically talks about politics. So we can see some of these guys speaking the F word and S word quite frequently. So that is all we need to know for now. We have seen how to render the word cloud for each of these comedians now, and based on this you can also clean our data a bit more. Like you can see the yes and yum has been frequently rendered, so you can change it. Now that is all in this video. In the next video we will dig deeper and check what is the level of profanity each of these comedian has spoken. Like we need to find what amount of F word and yes word, that is this comedian have spoken into their shows. So that is all in this video.